So when we are talking about the spinal cord reflexes, so one of the most common reflex that we talk about and that we observe and discuss is the muscle stretch reflex, and it is one of the most basic concepts of a spinal cord reflex. So in this lecture we're going to talk about the neuronal circuitry of stretch reflex, the dynamic and static stretch reflex, which are based on the static and dynamic response of the muscle spindle that we discussed in the previous lecture, and the role of muscle spindle in voluntary motor activity. So muscle stretch reflex, what is it and how does this happen? So as we already discussed, so there are specific receptor organs in the muscle which are known as the muscle spindle, and they are composed of the intrafusal muscle fibers. So here's an example that we have. This is the sensory nerve, which is taking the information from the muscle spindle through the sensory neuron to the spinal cord. And in a monosynaptic reflex, it terminates on a motor neuron, which then comes and supplies the muscle fiber itself. So let's suppose this muscle is biceps, for example. So whenever biceps is lengthened, that increase in length is actually perceived by this muscle spindle. And that results in a response or a positive response by the muscle spindle, which actually takes the information from the sensory nerve and it influences the motor nerve. And influences the motor nerve by actually activating the motor nerve, and the stimulation of this motor nerve actually stimulates the extrafusal fibers, which cause contraction of the muscle itself. So the innervation of the muscle spindle due to lengthening of the muscle in turn cause the contraction of the extrafusal muscle fibers and thus contraction of that muscle, which was actually a muscle stretch reflex because lengthening of the muscle resulted in contraction of the muscle. So another important phenomena which is associated with this muscle spindle function is damping in smooth muscle contraction. Because whenever we take a look at any activity, there is consequent contraction and relaxation, and that is occurring throughout the day and in any activity. So what happens is that there is contraction followed by relaxation or lengthening, and that leads to, you can say, uneven or jerky movement. So the ability to prevent oscillation or jerkiness of body movements is known as damping in muscle contraction. This signal averaging function of the muscle spindle reflex is thus very important for purposeful and coordinated muscular activity. As we can see that here is, let's suppose, a decerebrate or spinal animal, and here is a normal animal, and the contraction in both of these specimens, you can see the difference that here we have 8 contractions or 8 stimulations per second, but there is actually a very smooth curve for a normal animal, whereas there is a very you can say jerky curve for a decerebrate or spinal animal. Now moving on, the influence of this muscle stretch reflex or muscle spindle response is also very important in terms of voluntary motor activity, because 31% of all efferent nerve fibers to muscle are actually type A gamma efferents, which actually supply the contractile part of the intrafusal muscle fibers or the muscle spindle. Now, activation of these gamma efferents or the gamma motor neurons actually causes contraction of these intrafusal fibers. So whenever we need, let's suppose, a contraction, so there should be, let's suppose, here we have an example, and if there is a stretch reflex which is being occurred and because of the lengthening of the muscle, but normally we do need the muscle to lengthen, for example, for a purposeful movement, so there would be actually decreased stimulation of these gamma motor neurons. And when we are actually performing an activity in which we need to prevent the lengthening, so there would be an increased activity of these gamma motor neurons, and that would influence the response of the muscle spindle. The greater activation of the gamma efferents, the greater the muscle spindle response or more sensitive it becomes. The less the activation of the gamma nerve fibers, the less sensitive or the less response there is of the muscle spindle. So what is the function of the muscle stretch reflex in terms of voluntary motor activity? First of all, it keeps length of the receptor portion of the muscle spindle from changing during the course contraction, because whenever the gamma efferents stimulation occur, they contract, or whenever the inhibition of gamma efferent occurs, they relax the intrafusal part or contractile part of the muscle. That results in keeping the length of the receptor portion at a constant so that not to impair the voluntary movement. This is also important that it keeps the muscle spindle reflex from opposing the muscle contraction. So whenever a lengthening is required, as I already mentioned, there should be inhibition of the gamma efferents and thus decreased contraction or decreased resting tone of the contractile part of the intrafusal muscle fibers. And in this way, it maintains proper damping function of the muscle spindle, so the movement is not jerky, regardless of any change in the muscle length. Now, if we talk about the clinical applications of a stretch reflex, one very common is the knee-jerk reflex or the muscle tendon reflex. And this muscle tendon reflex can actually be checked at different, for example, at the level of the elbow for the biceps and triceps jerk reflex, at the level of knee for the knee jerk reflex, and it is also used to differentiate between upper and lower motor neuron lesion. So we take a look at this example. So whenever the clinician strikes the, you can say, the patellar tendon, that actually increases stress or the tensile stress or length of this musculotendinous unit. And that actually causes the activation of the muscle spindle organ, and that causes messages to be transferred via the sensory neuron to the spinal cord. Here, via the interneuron or without the help of the interneuron, it activates the alpha motor neuron, and these alpha motor neurons come here and they actually excite the quadriceps, and they actually results in the contraction of the quadriceps muscle and thus the extension of the knee in this example. So that is one of the clinical application of stretch reflex. Another clinical application of the stretch reflex is actually a clonus. For example, when someone is, let's suppose, standing on a stair in such a way that when he relaxes himself, his feet go into, or his ankles go into dorsiflexion, and there is a stretch on the gastrocnemius musculotendinous unit. So because of that stretch on the gastrocnemius musculotendinous unit, the muscle contracts reflexively because of the muscle spindle stretch reflex, and the person goes from the dorsiflexion to plantar flexion. And that person stays there for a while, and as the reflex phenomena dies out, he goes again into the dorsiflexion, and once again that stretch reflex phenomena occurs again, and the person goes into dorsiflexion and plantar flexion consecutively again and again, and that is known as the ankle clonus, which is an example of the clinical application of stretch reflex, and this is exaggerated in upper motor neuron lesion. So that was all about the muscle spindle stretch reflex. I hope you learned something new out of it. Keep on watching sqadia.com for more lectures like this. Thank you very much.